Switching over to the next presentation by Anna Lizinskaya, professor at Brown University, and Abhishek Singh at MIT on the cryptographic protocol for this user journey. Handing it over to Anna and Abhishek.
Hi, everyone. Let me share my screen. So I'm going to present the mechanics, what's happening under the hood. Assuming you can see my screen, right?
Yes, go ahead.
Okay, good. So what are the mechanics under the hood, things that are happening? So so first of all, let's focus on the problem statement. So what we want is at every stage of the vaccination journey, just as Ramesh said, we want the user to have something, some credential that they can show to, that they can use at this step. So at first, in the first stage, you have a proof of eligibility. Then you have a proof of partial or full vaccination. And potentially, if you have symptoms, then you need proof that that what you're submitting, that the symptoms you're submitting to the system are actually linked to the relevant vaccine. So what does that mean? We want these proofs to be hard to forge and hard to transfer to another user. So, and we want them to be very usable. So there are two types of proofs that we are currently looking at. One is something that fits on a piece of paper, so it's like a QR code. And the other one is based on an app, so that your device will do a lot of the work in presenting this proof. And of course, we're focusing, so both of these have to be machine readable. And a lot of the details are up for discussion. So one thing that's up for discussion is who actually issues these badges, these coupons. Is it the pharmacy or the state or the CDC? So those things potentially can be discussed. Right now, we're thinking that it's the CDC that provides the infrastructure for these, just so that everything is streamlined and similar. So the user has such a proof, can present it as needed, and there is no central database where there's a huge, there's no centrally aggregated personally identifiable information, so that you cannot have just one database where anybody's vaccination status can be stored. That's not what we want. We want a more privacy-preserving scenario. And of course, we want to make sure that the human effort is focused on the vaccination itself, so that everything that's has to do with issuing these credentials, verifying these credentials, happens behind the scenes and doesn't need everybody to be online all the time. So those are our goals. So what is our tool? So the main technical tool to meet these goals is a cryptographic signature scheme, so digital signature scheme. So if you've been following how the internet works, then you probably already know that a digital signature scheme is this amazing mathematical discovery that you use every time that you browse the web. So the S in your HTTPS stands for secure. So how does your browser knows that it's connecting to the server that you think it's connecting to? It checks the digital signature on this server's certificate, right? So your browser downloads the certificate of the site that it's connecting to. It verifies that the certificate has a valid digital signature, and then it uses that certificate to make sure that all the bits that it receives correspond to the owner of the certificate. So the tool powering all of that as you're browsing the web is a digital signature scheme. So this is exactly the same tool that we're proposing to use in this application. And how does it work? Well, I'm not going to tell you really how it works mathematically, but just in a nutshell, it consists of 3 algorithms. There's an algorithm that sets up these keys. So there's a key, a secret key, a signing key that you need every time you issue a digital signature. And you need to keep it secret, because if you lose it, then anybody will be able to issue your signature. And then there's a verification key that is needed for verification, and that one gets published. So, for example, the CDC can run this key generation algorithm, set up a signing key that it uses to sign the coupons that it can use to sign the badge, and then everybody has access to the verification key, so everybody can verify the coupon and everybody can verify the badge. So that's the first algorithm, key generation. Then there's the signing algorithm that needs the secret key, and you tell it what it is that you want to sign, and it produces a signature. And the verification algorithm that verifies a signature on a given message under the given verification key. And the point of a digital signature scheme is that it is unforgeable. So it is computationally difficult, infeasible to create a digital signature unless you have the corresponding signing key. So that's a very, very powerful tool. So let's see in context, how are we going to use it here? How do we propose to use it? So here's our Stroman protocol. So you have, there are several types of credentials. What do they look like? So your coupon, which is what allows you to obtain the vaccination in the first place, to get a shot, is just a signature that says, this is a coupon for this zip code, for this type of job, and there's a serial number I, and it is signed by, let's say, the CDC, so that you can present it, and it doesn't have a user's name on it, and potentially it's distributed via an employer or in some way that isn't connected to the user's actual identity. But the user goes to a vaccination site, such as a pharmacy, and presents this coupon. The pharmacy verifies that it's a valid coupon by running the verification algorithm of the signature scheme, and is ready to administer the vaccination. And of course, all of this is happening, it's automated. So the individual simply says, here's my QR code, and the pharmacist just scans it, and then the pharmacy's app says, sure, vaccinate this person, and there we go, and the user gets vaccinated. So badge is now a particular person got got a particular type of a vaccine. Sorry, the badge is attesting that the person who's presenting it got a particular type of vaccine. This is the first dose. So it's similar. And then the most interesting one, which is in the second row on the right-hand side, the pass key, that's the one that the user will go and show to a venue to prove that that they have been vaccinated. And that one now includes the user's personally identifiable information. And the reason for that is that when you present it, the venue might say, well, is this really your pass, or is this somebody else's? So because over there you have this identifiable user's personally identifiable information, the venue will be able to check that QR code against the user's ID. So we'll make sure that it's correct user. However, you might say, well, whoever issued this must have the user's PII. And the way we get around that is that information is not actually presented to the signer, which in this case is the CDC, in the clear. Instead, it is hashed down together with some random salt, random key, in such a way that when the CDC issues the badge, so the badge is above, so that's in the first row on the right-hand side is the badge. When the CDC issues this badge, the CDC does not know who the user is, does not receive any personally identifiable information, simply receives this passkey and happily, sorry, not the passkey itself, but the hash down version of the passkey and happily signs it. So this way, the CDC can issue these vaccination credentials without collecting personally identifiable information. Just knows this is the type of vaccine that was administered. And of course, there has to be a link, right? The CDC must have some amount of confidence that it issued the badge to a valid user. So this is where we have to trust that the vaccination site, the pharmacy, is actually connecting the dots and making sure that the information that is hashed down and then signed by the CDC accurately reflects the user, the user's information. And we're placing this trust in the pharmacy, but it isn't, it's up for debate, of course, it isn't too much trust because, of course, when you are there in person, the pharmacy already knows that you are there in person. They potentially know who you are anyway. And also they're trusted by the CDC to administer the vaccine. So they can also be trusted to correctly verify your ID and make sure that the correct identifying information gets inserted into this field for the passkey. Okay, so that's those are the nuts and bolts. And of course, what is very desirable, and luckily the state-of-the-art cryptographic digital signature scheme allow this, is that a digital signature should fit in the QR code. And luckily that is possible as well. Okay, so now our user goes, let's say, to the airport and wants to convince the ticketing, the gate check, the agent at the gate, that they have been vaccinated, so that they're clear to fly. So they can just show this QR code, and the venue will run the signature verification protocol to make sure that this user is in fact that presenting the correct credential and their PII matches what's on their ID. Now, it is possible that instead of a QR code, we want to do something a little bit more sophisticated, like an app. And of course, an app can also display a QR code. So this paper-based solution also translates into an app very easily. Okay, so now the question is, the Strawman, this QR-based proposal that I just showed you, does it solve the problem that I described in the first slide? And so our goal was to make sure that these credentials were ubiquitous and they attested a user's either eligibility to receive vaccination or vaccination status. So we wanted to make sure that this proof that the user received is hard to forge or transfer to another user. That is that property is exactly what is satisfied by a digital signature scheme. So that much we can be we can have confidence that we got this one right. Of course, what's up for discussion is who issues the badge. So who is running this cryptographic algorithm for signing? And the way I just presented it is we assume that it's the CDC. So the CDC is connected to the pharmacy. So when the pharmacy administers the vaccine, there's a live connection between the pharmacy and the CDC. The pharmacy says, here's what you need to sign for this vaccination. And the CDC responds with a signature. And that is potentially up for discussion. And in fact, it's a good idea to try to get this one right, because there are pros and cons to this scenario. The pro is that there's just one verification key, the one that's associated with the CDC, and one secret key, one signing key, that the CDC signing key. And we only just need to worry about the CDC keeping its signing key private, and everything is fine. But the disadvantage is that, of course, there's all this you have to be connected to the CDC all the time. And so it makes it harder to have some kind of a mobile vaccination drive where the connectivity is not as good. So that can be mitigated, but it's up for discussion. So one way to mitigate it is to say, well, the pharmacy itself can issue these signatures, and the pharmacy can be certified to do that by the CDC. And so this is up for discussion. And you can also imagine that there might be other tiers like the state. So that's that bullet I've addressed. So can the user present this proof as needed? Yes, assuming the user doesn't lose it. So if it's tied to a piece of paper with a QR code on it, we need to make sure that there's a way for the user to maybe back it up. Maybe the pharmacy has a backup of these QR codes so that the user can say, oh, I lost mine. The pharmacy can find it based on, approximate date of when it issued it to the user. But assuming that the user, the badge is still in the user's possession, that's a fairly straightforward. And very importantly, there is no central database that records these individuals. The information that the CDC obtains in this scenario about the users is simply, this is the type of vaccine that was administered. Is this the first dose or the second dose? And that's it. So there is no central database. So you cannot have a scenario in which people are worried about the entire vaccination process because they're worried that suddenly their data is going to wind up in some central database. That worry can be dispensed with. And we want to minimize connectivity and human effort required. So most of this is automated, but this is up for discussion. Perhaps we can do better. So that's the straw man. And then there is the monitoring part of it that Abhishek will address. So I'll skip this slide for now. So note that the strawman that I just discussed was paper-based. If you have an app, things can be more interesting because now you don't need to worry about just fitting all the information in the QR code. So an app might be able to handle a lot more interesting things. So for example, we can store a lot more information so that the users, why do we even have this PII, is so that the user cannot transfer their credential to another user. So if you have an app, then potentially you don't need to show your ID, the same ID every time you use this credential. You can embed in an app, oh, this is the number of my student ID. This is some other ID. So you can kind of embed a lot of other information in there, which you show as needed. And so an organization that already knows you by a certain identifier does not need to see all of your information. It can just say, okay, I trust this identifier. Oh, and it's the same identifier as in your badge. And moreover, even more interestingly, you can make it even more privacy preserving by just, if you have an app, instead of showing the signature in the clear, the app can just prove that it has a signature without revealing any other information in a way that's unlinkable, using unlinkable anonymous credentials. And then your privacy is really protected. Or you can also do, you can also embed interesting biometrics. So if you have an app, there's a lot more interesting stuff that can happen. And also apps help on the distribution state and streaming it and monitoring, which Abhishek will talk about. So just here's a summary slide of benefits and limitations. So the benefits of this approach that I've outlined so far is that you have more privacy. There's monitoring that's possible. And and the part that the information that the CDC does keep, it allows the CDC to keep some information, just not in a way that's connected to individuals. The limitations, as I mentioned, is that the pharmacy needs to do this. It needs to verify the information before it signs it. So the pharmacy has to do a little bit of work in order to make sure that the credential that gets issued is issued correctly. Then there is the, in the Strawman, as I said, the venue is verifying the vaccination status, and I do need to check a user's ID in order to make sure that it's the properly vaccinated user who is presenting the badge or the credential. And this can be mitigated by, for example, if you have a biometric reader, so the user just shows, like, puts his thumb to the biometric reader, and then that can be that can make it less work for the venue, because the venue just checks does the fingerprint that the user just submitted, does that match their badge? But that approach would require that the venue has some biometric reader, whereas just using a digital signature and an app that verifies a digital signature does not assume that. And then there's also possible limitations to the privacy of the overall system, is that if you don't trust the pharmacy not to collude with the CDC or some other central entity and submit your private information, then you might still be distrustful of the overall approach. And similarly, if the venues, if every time you go somewhere, that venue kind of keeps tabs on what you're doing and submitting this information somewhere, then again, you're not going to trust that your privacy is protected, although that part can be mitigated using anonymous credentials. Okay, so with that, I am going to hand it off to Abhishek. And as I mentioned, Abhishek is going to cover this monitoring idea and other aspects of the more app-based approach.
Thanks, Dr. Anna. I'll start sharing my screen.
Yep.
Yes, so my screen visible?
Yes.
Okay. So yeah, the last stage in the whole protocol here we have is monitoring. And the idea is for every user to submit or even monitor a potential adverse reaction or any associated symptom with a given vaccine. And the way we want to do here, the way we want to make sure that user privacy is retained at the same time they can do this monitoring as well as submit their adverse reaction is through, in a privacy preserving way, is through some sort of multi-party technique, because in the end they're uploading their data and it's like a health data, so it could be sensitive. And the very simple idea here is to just take the information and send it across two aggregators such that they can work on this, perform computation on this information at the same time do not get to know what information exactly it is. So to put it simply, let's say if a person wants to submit 0 or 1, and where 0 means they're not feeling any symptoms at all, and 1 means they're feeling some symptoms, what would they do is they would compute some secure share. So here, again, simple example is instead of sending 1 to one server, they will send 300 to one server and minus 299 to the other server. And now what happens, similarly, many other users submit this information to two servers. And in the end, when they compute the sum over it, they would still have the same number, which they would have got as a single server. But at this time, no single server got to see any sensitive information from the user. Again, I'm taking a very simple example of 0 and 1, but it could be much more complicated, and as well as it could also contain some personally identifiable information here. So that way we can perform some computation on this sensitive information at the same time do not reveal any identity. Now the second part here is publishing this information, because as we can see, when the data is very rich, even the aggregated information would reveal something about the population. And that could be dangerous, especially when the users are the early participants on this whole system. So for example, the first user who comes in will, of course, have to reveal their whole data in order to get the full aggregated statistic. So the way it is solved is we use some notion of plausible deniability. So the way we want to enforce this notion of plausible deniability is using either differential privacy, or some other methods of secure thresholding, where the idea is that whatever aggregate computation we perform, there is some amount of noise or some sort of thresholding such that participation of any user is not revealed just by looking at the statistic which has been published by the server. And this statistic can be used in a variety of ways by CDC as well as the vaccine companies, all pharmaceutical companies, and other researchers who are trying to study potential effects, and also monitoring how the system is evolving as we keep vaccinating more and more people. So overall, again, the idea is to upload data as well as download data. At the same time, perform some computation on it without revealing any identity or personally identifiable information about the user. So this is the whole monitoring ecosystem. And then zooming out here and looking at the overall system goal is to ensure that we support end-to-end flow. So 3 goals, which we have highlighted previously also, just summing them up again. Digitization of the existing system so that we achieve some extent of efficiency, coordination, scalability, which clearly are some of the big issues right now as we see the distribution of vaccines unrolling right now. And then privacy at individual level, because we want to ensure that individuals participate, as well as there's no unintended consequence of the information which is being collected here or transferred across different systems which are coordinating with each other. And third is also very important, which is interoperability, because there's already a well-built ecosystem around some of these things, like VAMs and vSafe, and we do not want to create any disruption and be incompatible with the existing systems. And as we discussed, if you want to view this whole ecosystem, it can be broken down in 4 stages. First is distribution, where we discuss how the coupon is distributed and how we use digital signatures to verify the coupon's validity and eligibility of the user. The second phase is where vaccination happens, and the second dose coordination also happens. Again, this is the vaccination phase where the user goes to the pharmacy, gets vaccinated, receive their records, and using these records, they go to third stage where credentialing happens, and it could be used for various purposes for getting entry. And the fourth stage, which is the post-vaccination phase, where adverse event reporting and monitoring happens. So with that, I would like to conclude, and thanks for the time.